Hello and welcome back. Today I like to show you my new find, and it is a huge dummy load, and it is from 1966 if I'm correct. But first I like to go through the dummy loads and the types that are available and why I actually picked this older one. When I use the name dummy loads, I really use it as a device that really, as a dummy, it loads the transmitter. You also have these little things, but these are also 50 ohms. But this is for me more like a Terminator, like you used in your Ethernet when it was coaxial, and or just on your test equipment if you have a generator and you want to put it on your oscilloscope. The impedance of the oscilloscope is usually 1 mega ohm, and you want to minimize your reflections. You put your terminator on the end, and then the line is closed. So that's a terminator. But a dummy load really loads the transmitter, so that's usually for higher power. So this one, I don't even know, it doesn't even have a wattage, but yeah, it's probably like 1 milliwatt, because usually it's like 0 dB. And then you have, of course, the toys. The light will go on when you start to transmit. Well, I have no idea if this is 50 ohms or not, so this is toys. And of course, you can build yourself. Here I have 10 resistors of, well, almost 50 ohms. Put them all in parallel, and it should do 3 to 5 watts. That is also nice. But what if we want big power? Well, of course, I was looking on the internet to find if there maybe were the new dummy loads available, and they are for 50, 60 euros. You have 300 watts, it says. Or if you want from MFJ, you have the 1.5 kilowatts or 1500 watts for about 150 or 200 euros. I think in the Netherlands they are around 220 euros. And then you can do 1500 watts. But then you need to be careful and look at the specifications. So 1500 watt means it is just 1500 watts for 30 seconds or 10 seconds. And it's really crazy, no? Then I think you cannot sell it for 1500 watts if it only does that for a few seconds. And then you look at continuous and it's maybe only 150 or something. So that is the biggest difference between these. And these you can still find secondhand, and you still pay a reasonable amount. I think they can be between 100 and up to 400 or 500 depending on the brand. For instance, the bird that I found, that one was around 400, I think. And yeah, but that one is rated for 600. But then if you look there in the specifications, it is 600 continuous, and that is the biggest difference. That's why it sometimes makes sense to look for a second-hand, as I have here. And this one goes up to 500 watts. And it is a huge resistor inside, and it is oil filled, and you can see it has a huge, huge heatsink. Well, if you want to build it yourself, instead of doing it like this is, I think, probably 40 years old. I built this ages ago. And but nowadays you can also buy these resistors. This one is 50 ohms for 250 watts, and you just use some temperature paste, and then you put it on a huge heatsink, and then this 250 watts you can probably do. But I would think exactly the same. It is probably not continuous. It also for a certain time, and that is really the biggest difference between these huge ones. So, and then what did I find? Well, this dummy load, I found it on my local eBay, and it should do 500 watts continuously. And well, it is a bit big, so and this one, it's big, and it has a big Powermeter in the front. I tried to clean it. I hope it still works because it's now very low. And you have different scales. For the resistor it doesn't matter, because the resistor can just do 500 continuously. And this is the L version, so it is just up to 30 megahertz. But you can do 500, 150, and the setting that they say that is switched off. but this switch is only for the power meter, and it is taking out of production. And if you wonder why, because this is made in the US especially for KLM, and it is from the Sierra Philco company, which was in that time a part of Ford Motor Company. So here we have a look at the label, and it actually says Terminator Wattmeter. But here I would use a Dummyload Wattmeter, because this actually used to load your transmitter. And we can see the type number. It's a 401A-500L, and I didn't find anything about this L version, but I did find a magazine from 1966 where they talk about the M version. And the M version, that was for 30 MHz and higher. And this one is the L, so it's specially made for the lower frequencies, and it says here up to 30. But it's quite big, takes a lot of space. It still looks good. I was thinking of painting it, but on the other hand I think, no, I'm just gonna leave it like this. It is old, and in that sense it is so, because it's from 66, it's more than 50 years, almost 65. And then actually it just aged, so then I don't mind. And the oil is still in. There is a little bit of air also, because of course the fluid, when it needs space to expand, because otherwise it will just try to get out, because you cannot compress fluids. And this is the only damage I found, and it's a little bit dirty, but we can clean that. And it has not been opened, and the meter seems to move still, so that can still be working. So let's try to put some power from my icon, and let's see if the meter still moves. So I'm just going to connect my icon. It can deliver like 100 watts on HF. So we just pick a frequency, let's say 21 MHz. It's on the dummy load, so it won't go far. And we start just with 10 watts. I compare it with my power meter here, and we compare it to this one here. This N connector, so I don't need any other weird converters. Just put on 500 watts, put my power supply. I'm going to need some current, because it probably goes around, well, 22 amps, 20 amps. I put it to FM mode. And let's go somewhere 20. I go to 25, why not? And low power. And yes, it is moving, so the meter works. Cool. It should be around 10 watts. Now let's have a look on the meters. So I have the power meter here in the back. It's now to 20 watts. So that means it's this scale here, 10, 20. And this one is to 150. So 10 would be right here, while the other 10 would be right there. So let's transmit. This one is a multi-band, but I switched it to the lowest band. So 1.8 MHz up to 160. So the readout should be okay. And indeed, well, it says it's a little bit more. So all the power meters say something different, but I will compare it to my Marconi, because I know that one is good. So I just want to open it, and maybe we can improve the look of the power meter itself, because it's kind of darkish. And of course I like to clean it. And but I like to see why the other ranges don't work, or what is behind it. Maybe they blew a resistor, and I can find out what the value is, or it's just a question of adjusting. I don't know yet, I haven't opened. The seal is still on it, so let's break the seal. It's a little bit big to put on my desk. But these dummy loads, because they are oil filled, they usually need to be horizontal when you use them. So I need to put them more on the floor. Okay, interesting. Look at this. The big meter itself, huge, huge meter. Two connectors here, big resistor, the switch here, and the two setting is now on 500, and I only see two cables. So that would be the two settings, but there is another difference. So one cable, second cable, and then the other two, it seems to push a button in here. So, and these cables are connected also to the others. So I'm not sure how that works. Because here you can see it is, now it pushes something here also. So that third one is then again connected to the first one, I think. And then the fourth, I don't know what that does. I don't see a loop and I don't see that extra connection. And here comes the top, the RF top. That is later probably just rectified and put into the meter. It looks like sort of mini BNC. Yeah, this is RF top thingy. So here we look at the other side and we just see two ports. So we can adjust things. So that is nice. So I can use that. So at least the 150 and the 500 setting we can do. Here we see that coax cable that comes from the, I think, the RF top. I see a diode here. Let's see if I can zoom in some more. Get the lighting different. Yeah, here is a diode. So I think they rectify it here to show it on the DC meter in the front. And in the end, it doesn't matter too much. No, they just need signal. It needs to be displayed. And as long as it is adjustable, that is good. A little resistor here on parallel of the meter, just to give it maybe a little bit more load. Well, there are all kinds of little mechanical tricks. Like I said, with the button that I push here, and I found a fourth wire. So these both settings could indeed be divided by 10 in this case. So the 50 becomes the 500 and the 15 becomes the 150. And it has to do with this thingy that goes in or not. And then I was just looking and I see here in the far in the back there is a little trimmer, but I don't want to touch that one. Here seems to be sort of a little antenna it picks up here probably, and this I don't know what it is. It doesn't seem to be able to be screwed, but here, and it okay, I took it apart, and what I think is the switch was pushing. It was pushing on this thing in the lower settings, but I think it should be touching there, this point there, because then without pushing it gets all the signal from this little thing here, and then for the lower power it gets its power also from this one, so then it gets more energy. And because the push switch didn't do anything, but it is not touching, so what I'm trying to do, I will put some, I think the same material. I will try to solder that on the side, so then when we push it starts to make contact again with that point, and hopefully I've got back then the contact So I try to fix it like this. Okay, I think I have the switch working. Have a look at the LCR meter. I put the plastic sticky that is pushed by the other switch, and if I push that now, have a look there, it goes to 0, and that means both the receiver metals will pick up RF signal, and then of course we get a lot more signal, so that is for the lower settings. So that seems to work now. So both conductors here, the switch is in the outer position, so there is no contact. I need to get exactly in the screw in the middle. That, okay, this is more than 100K. Now the still 100K. And now the switch starts to push. Here it is. 0 ohms, 0 ohms. So now both receptors will receive from the RF. Perfect. Okay, I put my transmitter to put 20 watts on 40 megahertz. I can try later a higher frequency, but just start here. And we see 20 watts. So now 500 watts. Yeah, that is too low. Also on this scale, 20 watts. Let me try to adjust it a little bit. How is this scale? 50, so it should be there. Let's try this one a little bit. Almost. So that's 20 watt there. Well, 15 of course will be too much. Now let's put the 150 scale. So we should end up right here and not here, because now it thinks it's 60 watts. Okay, I think I'm nearly there. I have now almost 100 watts, like 95. I put it in 500, that's the upper scale. It's almost touching the 100. On the 150 scale, it is just above the 90. And of course in the 50 scale, we need to try with lower power. Well, I think you can see 50 watts on the Marconi 49. So let's see how much that is on the dummy load. And its main purpose is a dummy load, but if we can sort of have a readout of the power, that is of course great. So first to 500, so it should be half. Well, of course it's less precise, but it is below half. Here it should almost touch 50. It does. Here it should be full scale. It is almost. 10 watts on the Marconi, 10.3. So let's see what that does on the dummy. Well, here on the 150 it should do almost nothing. Well, almost reach the 10, but of course you're very low in the scale. It would not make sense. It should get almost to there. And in the 15 it should go just above. And it says now it is like 9 watts, so I can add a little bit more power maybe. Then how is it in the 50? Yeah, here it is a little bit too much. Maybe I can do a little bit here. No. Nah, it is 10. So look at that. I'm very pleased with the result. I managed to get the color a little bit back, so it's now all light grayish. And this had some sort of a brown yellowish glaze on it. It still has, but it is a lot less. And the scale is now very clear. It was a pity that the sticker on the top, I think they took the serial number out. And that's why that is missing. And I managed to bend back most of the strips that were there and clean it a little bit. And I'm not going to paint it. I will just leave it as original as possible, because it just came in this color. So this side was a little bit more damaged, but also it is a lot better. So it has now again its full cooling capacity. And of course I'm really pleased that I was able to fix also the lower settings of the meter, which doesn't affect the dummy load at all. It is just an RF top and the signal that I then rectified and then display on the DC meter, and the lower settings because just didn't work because it has too little RF tops, and well, the lowest one was just not connected anymore. So pretty cool. So I'm really happy with the result. I've got myself a real big dummy load, 500 watts continuous, and yeah, that is more than I need. So that is good, because if you work on the limit, you can burn your the dummy load, and also its impedance could change. So it's better if it doesn't need to work too hard. And it is a real plus that the power meter now is working. And yeah, very good. Thank you for watching, and hope to see you next time.